Hello, and welcome to today's lesson on the period and frequency of waves. Our plan for this lesson is as follows. First, we will understand what the period of a wave is. Next, we will introduce the frequency of a wave. Finally, we will explore the relationship between period and frequency. So far, we have looked at classifying transverse and longitudinal waves and understanding the main features of waves, such as amplitude, wavelength, and speed. With this in place, we can now introduce period and frequency, further terminology essential to describing waves. The period of a wave is the time taken to produce one complete wave. It represents the time interval between successive identical points on the wave, such as the time from one peak to the next peak or from one trough to the next trough. The symbol for the period is t, and it is measured in seconds. For example, imagine a boy bobbing up and down on the surface of the water as a wave passes. If the boy takes 4 seconds to go from the top of one wave to the top of the next, then 4 seconds is the wave's period. We can now move on to the frequency of a wave. This is the number of waves passing a point each second. The symbol for frequency is F, and it is measured in hertz, where 1 hertz equals 1 wave per second. To visualize this, imagine standing on a dock and counting the waves hitting the dock. If 2 waves hit the dock in 1 second, then the wave frequency is 2 hertz. We can imagine the frequency of a wave in different contexts. For example, if a student shakes a slinky back and forth 3 times in 1 second, the frequency of the waves produced is 3 hertz. Now suppose instead we find that 30 waves hit the dock in 10 seconds. What would be the frequency? Well, if we have 30 waves in 10 seconds, then this means 30 divided by 10, which equals 3 waves per second, giving a frequency of 3 hertz. This leads us to understand that frequency equals number of waves divided by time. Note that this doesn't need to be a whole number. For example, if you had 5 waves hitting the dock in 10 seconds, then this means a frequency of 5 divided by 10, which equals 0.5 hertz, or half a wave passing by the dock each second. The period and frequency of a wave are inversely related. Let's work our way up to this finding. Imagine you're standing by the shore again, and you're counting how often waves hit the dock. If 3 waves hit in 6 seconds, that means each wave is hitting every 2 seconds. This 2 seconds is the period, the time it takes for one wave to complete a full cycle. Now, if we check how many waves hit per second, we would say 3 waves in 6 seconds equals 0.5 waves per second, which is the frequency. The more often waves hit, higher frequency, the less time there is between each wave, shorter period. Conversely, fewer waves per second, lower frequency, means more time between each wave, longer period. Hence, as the period of a wave increases, its frequency decreases. Conversely, as the period decreases, the frequency increases. Mathematically, this relationship is expressed as the time period equals 1 divided by the frequency, or the frequency equals 1 over the time period. For example, if the period of a wave is 0.25 seconds, we can calculate its frequency using the formula frequency equals 1 over the time period. So frequency equals 1 over 0.25, which equals 4 hertz. This means that the wave completes 4 cycles every second. In today's lesson, we explored the concepts of period and frequency as they relate to waves. We defined the period t as the time taken for one complete wave cycle, measured in seconds, and the frequency f was defined as the number of complete wave cycles that pass a point per second, measured in hertz. We then examined the inverse relationship between period and frequency, using the formulas time period equals 1 over frequency and frequency equals 1 over time period to calculate one from the other. Understanding the period and frequency of waves is vital in describing their behaviour. Watch the rest of the GCSE Physics course at Sophos Education.